Professor Belfrost's science class is back.
Okay, so hi, welcome back to this channel. I'm Professor Belfrost here, and today I will share with you another useful tutorials and courses to win your exam. Okay, and today I'll start with mathematics course, and the first mathematics must be pre-algebra and algebra, right? And this topic is actually consists of quite uh, many topics, quite fast topics. So I'll divide it into some videos, and this is the first video of algebra and pre-algebra. Just for this video, pre-algebra. Okay, so when we discuss about mathematics, about pre-algebra and algebra, we need to know some basic concept of mathematics. Because we are discussing about mathematics, we are discussing basically about numbers. Okay, so the most basic numbers we use in algebra are those to count objects. Yeah, like 1, 2, 3, 4, 5, so on and so on. Okay. So these numbers are called the counting numbers or natural numbers. Okay. The notation dot 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 is called an ellipsis to show and so on, or the pattern continues endlessly, infinitely. Okay. So yeah, these numbers start from 1 to infinite, to positive infinite. Okay, but if we want to add 0 to this set of numbers, then we have a new name for this set of numbers, which is whole numbers. So for these numbers, we can visualize them on number line, where the point label 0 is called an origin. Okay, so points are equally spaced to the right of the 0 or the origin and labeled with the counting numbers. Pair of number and point is called the coordinate of the point. Okay, but till now we haven't covered negative number. So now we want to expand it to the opposite, the mirror side. So we have a negative number. A negative number is just basically a number that is less than 0. We can visualize that both positive and negative numbers on a number line. Okay, I saw on the next slide. Tada! Here's the number line. This is very basic, right? Okay, so we have the 0 as the middle, as the middleman. The right one is positive numbers, and the left one, so we have negative numbers with us. Okay, so yeah, for positive number, we just need to add plus sign if we want, but customarily we just omit it and write only the number. But for minus sign, it is a must for you to write a negative sign, the minus sign in front of the number, or we will not know if this number is minus or positive. And how about 0? 0 is not a positive number and also not a negative number. It is neutral. Okay, so we can compare the value of a number because as it going from left to right on a number line, the numbers will increase in value and vice versa. Okay, we use the notation a less than b and a greater than b to show the comparison of the value. Okay, so you can see for the example, yeah, minus 2 is to the left of 1 on a number line, so minus 2 must be less than 1. So this is just a very basic concept for you to grasp. Okay, so on a number line, negative numbers just basically a mirror image of positive numbers with 0 in the middle, as the numbers are as the distance from the 0 to the number are same, and they both of these numbers are called opposites. Yeah, so minus 2 and 2 are opposites, minus 3 and 3 are opposites, minus 100 and 100 is just opposites. So, so far we have seen many ways to read the opposite notation, the minus, yeah, with different meanings. If we write it, for example, 10 minus 4, yeah, it is between two numbers. So the symbol indicates the operation of subtraction. We read it as minus, okay, minus 8, yeah, or negative 8. I used to say minus 8, yeah. This book use negative 8 terminology, just good. So in front of a number, the symbol indicates this is a negative number. This is opposite of the positive friend. Okay. How about uh, this notation used with any variable x? Yeah. So in front of a variable or number, it indicates the opposite. So we can read it as the opposite of x. How about the double thing? The opposite notation, then we have bracket or parenthesis, and inside we have another opposite notation with some number. Here we have two signs, okay? So the sign in the parenthesis indicate that the number is negative 2, yeah? Or negative any numbers, okay? But the sign outside of the parenthesis indicates that this is positive. So we read it as the opposite of negative 2. Yeah. This is just a way. The distance between 0 and any number on the number line is called the absolute value of that number. Okay, so I'm saying distance, not a factor. So a distance is never negative. It is always positive in value. Okay, so for example, absolute value of minus 5 is the distance between 0 and minus 5. It is 5, and it is written as, you can see the notation on the slide. Okay, when we multiply sign numbers, then the sign of the product depends on their signs, I mean the numbers that we multiply. This rule also apply the same to division, which is just basically an inverse operation of multiplication. With division and multiplication, if we are operating on numbers with same signs, then the product or the division must be positive. And if we are operating on different signs, then the product or the division must result in negative result. For example, minus 9 times 3 equals minus 27. Negative 2 times negative 5 equals 10. 15 divided by 3 equals 5, etc., etc. Okay? This is just very basic arithmetic, okay? Algebra. Okay, but yeah, this is another property of division. So division of number by minus 1 always give its opposite. Okay, so a divided by minus 1 or negative 1, yeah, it depends on you how to say it, equals negative a or minus a. Okay, a fraction. Now we have done with integer. Okay, we now enter the realm of of fraction. So a fraction is a way to represent parts of a whole. Okay, so it is written as a over b, where a and b are integers and b not is not 0. Okay, because anything that's divided by 0 will cause the division to produce to result in undefined situation. Why undefined? Maybe I will make a video on it, okay, a separate video, just maybe a vlog, for example. Okay, we'll see why any numbers divided by 0 will result in undefined. Okay, this is just fraction. Okay, how about a mixed number? So a mixed number is a number consists of a whole number and a fraction. So it consists of, say we have a whole number a and a fraction b over c, where c is not 0. Okay, so for example we have 1 2/3. Okay, so 1 and 2/3 is a mixed number. How about improper fraction? Improper fraction is a fraction with numerator greater than or equal to the denominator. So its value is always greater than or equals 1. So improper fraction must always be converted to a mixed number. Yeah? Because this is improper fraction. It's not yet solved. Okay. When a fraction has a numerator that is smaller than the denominator, then it is called a proper fraction. That is the first fraction that we dealt in the last slide. Okay. To convert between improper fraction and mixed numbers, first divide the denominator into the numerator, identify the quotient, remainder, and the divisor, so we can arrange it in a configuration as shown in this slide. Okay, quotient, and then the right side is the remainder of the divisor. I mean, okay. In equivalent fractions are fractions that actually have the same value. It is expressed with different numerators and denominators, but actually the value remain the same because you can just create it by multiplying both the numerator and denominator with any numbers that you want. Okay. For example, we have 2 over 4, 2 by 4. Yeah, 2 by 4 is just half times 2 by 2, right? You can also write the equivalent 3 over 6, 3 by 6, okay? 3 by 6 just half times 3 by 3, okay? It follows the property if A, B, and C are numbers where B is not 0 and C is not 0, 2, then A over B equals A times C divided by B times C. There are many grouping symbols that are used in algebra. We have parentheses, we have brackets, we have braces, we have absolute value bar, and fraction bar, okay? Absolute value line. Okay? Writing a number with a decimal is known as a decimal notation. So it's just a way of showing parts of a whole when the whole is a power of 10. So a decimal is just a system, a number system using 10 place. Okay, so we have 10 to 0, 10 to the 1, 10 to the 2, 10 to the minus 1, 10 to the minus 2, etc., etc. So we base on 10, power of 10. Okay. In other words, decimals are another way of writing fraction whose denominators are always powers of 10. Just as the counting numbers are based on powers of 10, decimals are based on powers of 10. Okay, so you can see I've summarized for you how to do the counting number and writing reflection in decimal notation. Now we are to be introduced the concept of place value. Okay, so you see place value on a decimal system. So the separation between the integer digit and the decimal, the point decimal is just the point itself, you see. The middle is point. There we have ones, tens, hundreds, thousands, 10,000s, 100,000s. And then on the right we have tens, hundreds, thousands, 10,000s, 100,000s. Okay, so from this diagram, from this table, notice there are two important things. The th at the end of the name means the number is a fraction, so 1 over something. Okay, so 1000 is a number larger than 1. Okay, but 1000th th, yeah, is a number smaller than 1. 1 over 1000. Okay, 1 over 1000. Okay, the tens place is a first place to the right of the decimal, but the tens, so once again, tenth and tens place is two place to the left of the decimal. So be very careful. But I think that this is just an elementary subject, right? Okay, so now decimal. So I haven't entered the discussion on rational and irrational number, but we will see it that soon. So a repeating decimal. A repeating decimal is just a decimal in which the last digit of the group of digits repeating endlessly. Like when we express 4 by 3 as 1 times 8 1 times 1.333333, it never ends. So we just place a upper line on the tree, meaning that the line above the tree tells us that 3 repeats endlessly. The pattern always occurring, 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 and keep occurring. Okay, how about if we have a number right uh, 0.271271271271. You can also express it as 0 point line over a line above 271. Yeah, meaning that 271 is the repeating block. Okay, so there are many important concepts. Numbers used for counting or enumerating things called natural numbers or the counting numbers that's on the first line. The set of natural number plus zero is called the whole number that is also in the first line. The set of integers adds the opposites of the natural numbers to the set of the whole numbers. Minus 3, minus 2, minus 1, 0, 1, 2, 3, and ellipsis. Also, the negative will also have prior ellipsis. There is sets of integers. So integers is any natural number plus the negative part, the opposite part. Okay. Then we have rational numbers. The rational numbers is just fraction that contains integer both for the numerator and the denominator, and the denominator is never zero. So because it is rational, it can be expressed as a fraction. That is the important thing. Okay, so every natural number, whole number, integer is also a rational number with denominator of 1. Okay. So note, any rational number can be represented as either a terminating decimal. For example, 50 over 8 is 1.875. You can cross-check it. Or a repeating decimal. Yeah? For example, 4 over 11 equals 0.363636, etc., etc. Okay? Numbers that cannot be written as fraction of two integers, then we call it rational. That is not rational, it's not repeating, and it's not terminating. Yeah. For example, you have the square root of 11, or you have some numbers, very irregular numbers as shown in this slide. Okay. Sets of rational and irrational numbers together make up set of real numbers. So actually there are two kind of numbers. We have real numbers and we have imaginary numbers. But I didn't discuss imaginary numbers here because we'll not see this number till we learn, yeah, maybe one or two next chapter. Okay, we can create a diagram to show the relationship between sets of numbers. I want you to take screenshot on this slide and learn it by yourself. Okay, learn it by yourself, understand completely. Okay, so we have done with the basic, and then we are now trying to explore more about first exponent. Okay, so when we multiply a number by itself, we square it or raise it to the power of 2. Okay, but actually can raise any number to any power. It means that we keep multiplying the number by itself. Okay, so for example, if we have the exponential notation of a to the n, means that the number or variable a is used as a factor n times. Yeah? There is the formula on the slide. Okay, where a is called the base and n is just the exponent. There we have a exponent concept already for us. Okay, so actually exponent is just kind of multiplication. Okay, now we are to learn how to evaluate the operation. I think all of you have known this concept for so long, but I just review it. Okay, so there are rules for evaluating any operation or mathematical expressions. That's acronym is PEMDAS. P stand for parentheses, E is exponents, M is multiplication, D is division, A is addition, S is subtraction. Okay, so there are 4 steps basically. Okay, first, simplify an expression within grouping symbols. Okay. Second, simplify any expressions containing exponents or radicals. Third, perform any multiplication and division in order from left to right. Fourth, perform any addition and subtraction in order from left to right. Okay, so now we enter the property of real numbers. So for real numbers A, B, and C, we have some property. First is commutative property. Yeah? We can do commutation. I mean that we switch place and the result will be the same. A plus B is just basically the same as B plus A. Yeah? It doesn't matter you add 2 plus 3 or 3 plus 2, it always equals 5. It doesn't matter you multiply 2 times 3 or 3 times 3 also 6. Okay. The second is associative property. So a plus in bracket, in parentheses, I mean, b plus c equals, in parentheses, a plus b, and it means that it's solved first, then we just add c to the result. That is the same, okay? Also, it applies to multiplication. A times, in parentheses, bc, is also equals to a times b first, in parentheses, then we times c. Yeah, we multiply with c. That's just the same. It doesn't affect the result that we get. Okay, that's associative. The third property is called distributive property. Yeah? A times, in parentheses, b plus c equals a times b plus a times c. Then identity property. Okay? For addition, the identity property states that there exists a unit where numbers called the additive identity 0, the number 0, such that for any real number a that applies a plus 0 equals a. So we back with the number itself. That's called identity property. For multiplication, the number is 1. Okay, so there exists a unique real number called the multiplicative identity 1 such that for any real number a times 1 equals a. Yeah, because any numbers times 1 always a. Okay, even 0. 0 times 1 also 0, right? Then we have inverse property. So for addition, the inverse is just opposite, right? I've told you before. Okay, for every number, a has an additive inverse or opposite denoted as minus a, such that a plus minus a equals 0. While for multiplication, every non-zero real number a has a multiplicative inverse or the reciprocal. Yeah. So if for addition the inverse is called the opposite, for multiplication the inverse is called the reciprocal. Okay, denoted by 1 over a, 1 by a, such that a times 1 over a equals 1. That's very simple, right? Okay, now I think we have done for the first part. I will not make it longer. Let's practice, okay? So I want you to classify each number as being a natural number n, whole number w, integer I, rational number q, and or rational number q apostrophe. Okay. So first, square root of 36. So we know that square root of 36 is just 6. It is natural. It is, yeah, it is a whole number. It is integer too. That's rational, but it's not irrational. Yeah. So if one number belongs to rational, it cannot be irrational at the same time. Okay. Is you just have to pick one. Okay. Now, how about 8 over 3? Clearly, this is not an integer because this is a fraction. Okay. Is this a whole number? No, because this is not a whole number, then this is not a natural number too. Okay, but this is rational. Okay, so Q, the correct option is just Q. How about square root of 73? Yeah, it's very clear that this is not a natural number, this is not a whole number, this is not an integer. But is this a rational number? No, yeah, because we cannot simplify it like the square root of 36. We cannot have any integer with it. This is not a rational number, so it belongs to a rational number. Okay, then minus 6. How about minus 6? Yeah, of course this is whole number. Yeah. Oh, I'm sorry, no, this is not a whole number because this is negative. I'm sorry, I misstated, but this is integer. Okay, this is integer, and this is a rational number. Yeah, but this is not a irrational number, right? Okay. How about the E option? There is not euro, right? There's E. I mean the E option, 3.21211211112. Yeah. Of course, this is a non-terminating and not defined. This has no defined pattern, right? So this cannot be natural, this cannot be whole number, this cannot be integer, this cannot be rational. This must be a rational number. Very simple. Second, use the order of operations. Evaluate each of the following expressions. First one, we have A, yeah, as on the slide, and B as on the slide too. So we solve it step by step. Okay. For the first one, Then I want you to simplify first the grouping symbols or the radical. Which one? 11 minus 2. Okay, we can simplify it to a 9. Then we just take the square root of 9, that is 3. So we have simplified the radical. And now we simplify the exponent. Which exponent? 5 to the 2. Okay, so we have extract the form. We have create new form, 35 minus 5 over 7. So we simplify the subtraction in the numerator. We have 21 over 7 minus 3, and then we simplify the division. We have 3. 3 minus 3 equals 0. Just a very regular subtraction, right? How about B? Also B is very simple. So 7 times 5 times 3, but 5 times 3 in parentheses. So it must be solved first because that's just the rule. Okay, right? And minus 2, yeah, we have also absolute notation. Inside the absolute notation, we have 6 minus 3 first to be solved because it's in parentheses, minus 4 squared, okay, plus 1. So we solve the 6 minus 3, 3, and we also solve the 4 to the 2, yeah, 4 squared, 16. Then we have 7 times 15 minus 2 times negative 13 plus 1. We just subtract it, okay? We have, and we just multiply each of the term, yeah? 7 times 15 become 105, 2 and negative 13 just 26, positive, yeah? You can just write it as minus in bracket negative 36, I don't mind, yeah? But finally we have the addition value, that is the summation value, that is 132. That's just very simple. There's the third one, the last one, I think. So yeah, I have a problem, A, B, C, D, E. Actually, this is just to test you if you can state the property of the real numbers that is used to solve this expression. Okay, so 3 times 6 plus 3 times 4. So you just can factorize the 3 using the distributive property and then simplify it using the addition, 6 plus 4. So 10, 3 times 10, 30. Okay, how about 5 plus 8 plus minus 8? Okay, you can also use the first is just associative first. You can change the parentheses to solve the second and the third term before the first term be calculated with the second. Okay, so we have 8 plus minus 8, and you know that plus and minus 8 is just what's called the inverse, the opposites. So this is just the inverse property of addition being applied, and 5 plus 0 just any identity property of addition. Okay, fine. So, and next, yeah, 6 minus 15 plus 9, that's also simple. You can use distributive property, okay, because you can solve 15 plus 9 first, okay, or yeah, I mean that you just apply the minus sign inside the parenthesis term, right? So we have 6 plus minus 25, and it can be simplified further to be minus 18. Also, we have fractions. We apply the commutative, associative, inverse, and identity property, and we get the result. Okay. And also the same as E actually. I want you to pay attention to this. This is just very simple. I'm not explaining it very long because okay. So that's the pre-algebra lesson for today. Actually, this is just pre-algebra thing and a little algebra. Okay, we haven't done yet. They are still long. Yeah. So yeah, this is a little inspiration for you. Steve Jobs once said, "Your time is limited. Don't waste it living someone else's life." Okay, that's all for today. Lesson. Thanks for watching. Here's your to-do list. Subscribe, give a like, comment, and share this video to your friends. And my class will be on every Tuesday, Thursday, and Saturday. So keep watching and be thoughtful. Goodbye.